So good day everyone, my name is Gemaline C. Carino and I'm from Group 10. So we're going to discuss represent quadratic function using equation, table of values, and graph. So objectives. At the end of the lesson, at least 85% of the students would be able to identify quadratic function that is written in the form of table of values, graph, and equation. Follow the step-by-step process and illustrate the 3 ways to represent quadratic function and appreciate the value of calculating equation to make table of values that we'll use to create graph in exploring quadratic function. Let's go for the introduction of quadratic function. Quadratic function. A quadratic function is a second-degree polynomial represented as f of x is equal to ax squared plus bx plus c, or y is equal to ax squared plus bx plus c, where a, b, and c are real numbers but a is not equal to 0. Example, 6x squared minus x minus 2 is equal to 0. Y squared minus 5y plus 4 is equal to 0. So as you can see here, we have the pattern. Number multiplied to variable squared, positive and negative. Number multiplied to variable, positive and negative. Number is equal to 0. The graph of quadratic function is called parabola. So we have here the different parts of parabola. Number 1 is the vertex. Number 2 is opening of parabola. And number 3 is the axis of symmetry. So dito tayo sa parts of a parabola. We have here the Cartesian plane. So yung vertex, yun yung pinakababa. Yung pinakababang pinag-intersecan ng linya. So yung axis of symmetry naman, siya yung nasa gitna ng vertex. Wherein yung naman, opening of parabola, yun yung end ng arrow. Ayan, yung end ng arrow, yung opening of parabola. Next na po.
So let's now have a representation of quadratic function using equation. So to represent quadratic function using equation, so as we all know, based on the definition, the standard form of a quadratic function is ax squared plus bx plus c is equal to 0. Once the expression are already in standard form, then we can identify the values of a, b, and c. So let's have first the example number 1. So here in example number 1, we have the expression x squared plus 9x is equal to negative 8. So the first thing that we need to do is we are going to transform first the expression into in standard form. So to do that, we are going to apply addition property of equality by adding positive 8 both sides to cancel out the right side, like this. We're going to cancel out negative 8 and 8, and we now have x squared plus 9x plus 8 is equal to 0. So since the expression are now in standard form, we can now identify the value of a, b, and c, where our a is equal to 1, our b is equal to 9, and our c is equal to 8. Example number 2. Here in example number 2, we have the expression 5 plus 2x squared is equal to negative 9x minus 5. So as you can see, in example number 2, it is also not in standard form. So we have to solve it first to make it in standard form. So to do that, the first thing that we need to do is we are going to apply addition property of equality by adding positive 9 both sides, and we're going to cancel out negative 9x and 9x, so that we have 2x squared plus 9x plus 5 is equal to negative 5. So as you can see here, we still have negative 5 at the right corner. But so we need to make it 0. So to do that, we are going to apply addition property of equality by adding positive 5 both sides, like this. So when we add positive 5 both sides, the right side will cancel out, and now we are going to combine the like terms, which is 5 and 5. Therefore, our answer is 2x squared plus 9x plus 10 is equal to 0. Since this is now in standard form, we can now identify the value of A, B, and C, where our A is equal to 2, and our B is equal to 9, and our C is equal to 10. So let's proceed now with the example number 3. So here in example number 3, we have the expression y is equal to 2x multiplied by x minus 3 plus 5. So the first thing that we need to do here is to distribute first 2x to x and distribute 2x to negative 3, so that we will get the answer 2x squared minus 6x plus 5. So since this is already in standard form, we can now identify the value of A, B, and C. So our A is equal to 2, our B is equal to 6, and our C is equal to 5. So to discuss the representation of quadratic function using table of values, may I call on my member, Mr. Warren Castroverde.
Okay, thank you so much, Kenneth. So, my name is Warren, and I'm from the group 10 also. So I will be discussing to one of the way of representing a quadratic functions. So this is the using of table of values. So what is a table of values? A table of values is a graphic organizer or or chart that helps you determine two or more points that can be used to create graph. Next slide. To know if the table of values presented a quadratic function, we need to get the difference in y by subtracting the data from right to left. So, and we need to make the answer equal at the second trial of subtracting data. Okay, so it means the table of values is the one that we use to representing quadratic functions. So we simply substitute the value of x to the given function so that we can get the value of y. So in example number 1, so let us consider y equals x squared. So the table of values here is we need to substitute the value of x, which is negative 2, to the function to get the value of y. So negative 2 substitute to the x squared, square root of negative 2 is 4, and so on and so forth. And next, as we find the value of y, we needed to minus or get the difference, inverse difference in y. And since it's a quadratic functions, the first difference in y is not equal to the first difference in y. But if we get the difference in y on the second, and we get the same answer. So it means this function is a quadratic function. Since the second difference are equal, therefore this table represents a quadratic function. Example number 2. So let us consider y equals x squared minus 4. So again, we substitute the value of x to the given function. So negative 3 squared minus 4 equals 5. And negative 2x squared minus 4 equals 0. Negative 1 x squared. Negative 1 squared minus 4 is negative 3. 0 squared minus 4 is negative 4. 1 squared minus 4 is negative 3. 2 squared minus 4 is equals to 0. And 3 squared minus 4 is equals to 5. So again, we get the first difference in y. So by getting the difference of 5 from left to right, so we get that values. And since we are talking about quadratic functions, the first difference in y is not the same. So we need to get the difference of y in the second part. So as we can see, um, the values are equal in the second difference. Therefore, this table represents a quadratic function. Next, example number 3. So we get, for example, the function of x equals to x squared minus 6x plus 5. Again, substitute the value of x to get the difference. So x equals to 0, substitute the 0 from x on the given function. So first in y, we get 5. And also, we substitute 1 to the x squared minus 6x plus 5, 1 squared minus 6 times 1 plus 5. So 1 minus 6 plus 5, so we get 0. And also x equals to 2, substitute the 2 to the x, 2 squared is equals to 4. 6 times 2 is equals to 5, 12 plus 5. So 4 minus 12 plus 5 is equals to negative 3. And so on and so forth. So we need to remember that we going to substitute the value of x to the value of y. So again, we get the difference of y from each value of y. So we get first difference in y. So it's negative 5, negative 3, negative 1, and negative 1, and negative 3. And also the second difference in y, which represents that this table is quadratic functions. Okay. Next, also I discussed the to represent the quadratic function using graph. Okay, the graph of using graph. So the graph of a quadratic function is called a parabolic. It is basically a curved shape opening up or down. So it's basically when you have quadratic function in form y equals ax squared plus bx plus c. So condition in graphing quadratic function. So if a is greater than 0, then the graph opens upward. And if a is less than 0, then the graph opens downward. Okay, example number 1. So we are asked to sketch the graph of the function of x equals to x squared minus 2x plus 3. So first, we need to get the table of values of this one. So the x is negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. And if we want to get the value of y, we need to follow the steps on previous topic, which is substituting the x to the function. So we get 18 and 11. Okay. We will be going to sketch a graph. Okay, so for now, we will be using a FluidMath to graph the function f of x. The example number 1, this f of x equals to x squared minus 2x plus 3. So as we just said earlier, we will be going to represent these quadratic functions in graph. So we will be plotting the values of x and y. First is negative 2 and 11. So, okay. And second is negative 1 and 6. 0 and 3. 1 and 2. Next is 2 and 3. Again, is 3 and 6. And lastly is 4 and 11.
4 and 11 here.
Okay, so after we plot these values of x and y, we will be going to connect these dots. So, yun. Okay. So as we can see, it is parabolic graph. So we can confirm that this function is a quadratic and it is upward. Tama ba? Upward ba yung ganyan?
Apo.
Upward. Upward because the A is positive or less than or greater than 0. Okay, so another one. Okay, so we will be going to plot another function which is function of x is equals to negative x squared plus 2x equals to 1. Okay, so we have here the values of x and y. So we will be going, what we are going to do is to plot this one, the Cartesian plane or to the graph, so that we can confirm if it is to represent rather the quadratic functions. So first, the values of x and y is negative 3 and negative 16. Okay, so we plot the negative 3 and negative 16. Next is negative 2 and negative 9. Okay. Next is negative 1 and negative 4. And next is 0 and negative 1. That one here. And next is 1 and 0. So this is the location of that. And next is 2 and negative 1. And lastly, it is 3 and negative 4. Okay, so after that, we will be going to connect this dots to make a parabolic graph, which is represents the quadratic functions fx or f of x equals to x squared plus 2 negative x squared plus 2x equals 1. So we can confirm that it is a quadratic functions and it is downward because it is a is less than to 0. Downward. Less than to 0. Okay. That's it.
So let's proceed now with our last example. So in our last example, we are going to represent only one expression in 3 different ways. So since we already discussed the 3 ways, let's proceed now with the example. So our example number 3, our problem is f of x is equal to negative x minus 3 multiplied by negative 2x plus 1. So here, Since we already discussed the three ways on representing quadratic function, let's represent this expression in equation. So to do that, we need to transform this into standard form. So to transform this into a standard form, we need to apply or use FOIL method. So FOIL method where we are going to multiply negative x by negative 2x. So we have 2x squared, negative x multiplied by 1, we have negative x, negative 3 multiplied by negative 2x, the answer is positive 6x. And negative 3 multiplied by positive 1, the answer is negative 3. Now we will going to combine like terms. So this is the like terms, negative x and positive 6x. So therefore, our quadratic function is 2x squared plus 5x. Since positive and negative, when you combine it, you are going to subtract. And since the highest exponent is, and since the highest value is positive, therefore we're going to use positive sign and bring down 3. So this is now the standard form of this expression. So we can now create our table of values. So our table of values, let's write table of values here. And table of values is composed of x and y. So let's use the negative 2, negative 1, 0, 1, and 2. So for this one, we are going to solve, we need to solve it. Wait, let me write the box first. So the box here, box. Sorry for my lininess. There you are. So let's solve first using negative 2. So here, we're going to let that x is equal to negative 2. So we have 2 multiplied by negative 2 squared plus 5 times negative 2 minus 3. So 2, so negative 2 times negative 2, the answer is 4. So positive times negative, the answer is negative. So 5 times 2 is 10 minus 3. Next, 2 times 4 is 8 minus 10 minus 3. 8 minus 10 is negative 2 minus 3. Therefore, our first value is negative 5. So we are going to write here negative 5. Next, let x is equal to negative 1. So here we are going to substitute again. Therefore, we have 2 times negative 1 squared plus 5 times negative 1 minus 3. Here, we have to bring down 2. So negative 1 times negative 1 is actually 1. So positive times negative, negative again. So 5 times 1 is 5 minus 3. So simplify, we have 2 minus 5 minus 3. 2 minus 5, the answer is negative 3. Minus 3, the answer is negative 6. So this is our second value. So we have here negative 6. Next, proceed with the next one. So our next is here, we will going to let our x is equal to 0. So since we have 2 multiplied by 0 squared plus 5 times 0 minus 3. So since this is multiplied by 0, it is actually 0, right? So cancel this out. Therefore, our x is negative 3. So let's write here negative 3. Next, we were going to let our x by 1. So we have to substitute it. So 2 times 1 squared plus 5 times 1 minus 3. So 1 times 1, the answer is 1. So positive 5 minus 3. Since 5 times 1 is 5. So simplify, we have 2 plus 5 minus 3. So 2 plus 5 is 7 minus 3. The answer is 4. Therefore, 1, the value of y in 1 is 4. And for our last one, we're going to let our x, our x is equal to 2. So we have here 2 times 2 squared plus 5 times 2 minus 3. So 2 times 2 is 4. So 2 times 5 is 10 positive minus 3. 2 times 4 is 8 plus 10 minus 3. So 8 plus 10, our 18 minus 3, the answer is 50. Therefore, this is 50. Now, since we have here the table of values, we already have here the table of values. Let's graph it now. So we were going to insert some graphs. So we have here graph. Let's insert graph. So for your information, guys, I'm using FluidMath. So FluidMath is an application, a whiteboard application for everyone. So here, okay, harangan ko na lang po yung solution. So yan. So as you can see there. Okay, now let's plot our table of values to identify the graphs. So here we have -2. This is the -2 part. This one. So let me use red. Okay. So we have -2 by -2 and -5. So this is -2 and -5. 1 and -6. So this is 1 and -6. Okay, let me arrange first the graphs. There you are. So next is 0 to -3. So this one is 0 to -3. This is 0 to -3. 0 to -3 here. Then 1 to 4. This one is 1 to 4. Then 2 to 15. So this is 2, 15. Then graph it. So we have to create line. So that is the line. So that is the line of our expression f of x is equal to -x minus 3 multiplied by -2x plus 1. Therefore, this is a quadratic function. This quadratic function. So that will be all, everyone. Thank you for listening. So we hope that you learn on how to represent using quadratic function, using equation, table of values, and graphs. That will be all. Thank you. Once again, my name is Mark Kenneth Quinto.
My name is Warren Castroverde.
And I'm Gemaline C. Carino.
And we
We
are
are
the Group 10.